Okay, see in this presentation, I'm going to discuss the number of hemophilia carriers in a population. When we discuss the calculation of hemophilia carriers, we in fact want to know the number of females who carry the disease allele, that is hemophilia disease allele, on their one of the X chromosomes. Because hemophilia is a sex-linked character. And males, since possess single X chromosome, they will either be normal persons or they will be suffering from hemophilia. But females, they are mainly carriers in the population. Okay, so they will have one normal allele on one X chromosome and another disease allele on the other X chromosome. And the number of sufferers, hemophilia sufferer females, are very, very less in the population. So let us see how such calculations of hemophilic carriers could be done. This I am going to explain by considering an example. In a human population of 4,000, there are two males diagnosed with hemophilia. Assuming this population is 50% male and 50% female, how many female carriers of hemophilia will there be? This is the question. That a human population comprises total 4,000 persons in a particular place, and out of those 4,000, two male individuals are actually suffering from hemophilia. Another thing is that if 50% of this population is of male, it means 2,000 individuals are male and remaining 2,000 are females. Then how many carriers, means how many females would be carrier in these 2,000 uh, females, that we have to calculate. We should know that hemophilia is a sex-linked disease. Males being hemizygous means they have a single X chromosome. Males being hemizygous show the disease more frequently than females. And females are mainly carriers. So only those females suffer from hemophilia who carry disease allele on their both X chromosomes. Now we can calculate the carriers, hemophilia carriers in this population by solving this question. Total number of individuals in the population are 4,000. 50% of them are males, it means they are 2,000 in number. Females, they are also 2,000. And frequency of hemophilia, that is Q, means since those people who suffer from hemophilia, they will have the alleles. Okay, so that frequency could be indicated by letter Q, and normal allele, its frequency will be P. So the frequency of P and Q could be known by considering the male individuals. So two individuals out of 2,000 males, they suffer from hemophilia. It means its frequency is 0.001. So this becomes the frequency of Q, and the frequency of P in this male population will be equal to 0.999. Okay, and if we have to calculate the frequency of carriers, then that we can do based on the frequency of P and Q. So frequency of carriers will be denoted as 2pq, and this 2pq, when we will calculate, then what we will do, 2 into 0.001 into 0.999, and this comes 0.001998. Okay, when we multiply 0.999 with the frequency of Q into 2, then this will be the figure, that is 0.001998. Now we have to calculate total number of carriers in the population. So carriers will always be only females, and females are total 2,000 in number. So when we have to get their number, then this 2pq will be multiplied with the number of female individuals present in the population. Thus the number of carrier females will be 0.001998 into 2000, and this will come 3.996. It means nearly 4 females are carriers in this population.